It begins the way so many discoveries do, quietly. No alarms, no headlines, just a line of data drifting across a screen in the early hours of the morning. Somewhere on Earth, while most of the world is asleep, an automated telescope is scanning the sky, frame after frame, dot after dot. Then, one dot moves faster than the others. At first, it doesn't feel special. Space is full of moving things. Rocks, ice, old debris left behind by the birth of stars. The system flags it anyway. Routine procedure. Another object crossing the ecliptic, the flat plane where planets travel, like lanes on a cosmic highway. Astronomers give it a temporary name, a cold label, something that says, we've seen this before. They assume it's distant, assume it's natural, assume it will behave. But assumptions are dangerous things, because when the first full data packet arrives, someone hesitates. Not because it's dramatic, not because it's obvious, but because something feels off. The object is moving fast. Faster than expected, not impossibly fast. Not yet, just fast enough to make you double-check the numbers. So they do. They rerun the calculations. They check the timestamps. They correct for Earth's motion. They correct for lens distortion. They correct for everything they can think of. And the number doesn't change. The object is cutting across the sky at an angle that doesn't quite fit. Its path is clean, almost too clean, like a stone skipped across water instead of falling straight down. At this point, nobody is panicking. There's no reason to. Space is weird. It always has been. But the quiet flaw is already there, hiding in the discovery data. It's subtle, easy to miss, and that makes it worse. The brightness of the object, its reflected light, doesn't match its speed. It should be dimmer or farther away, but it's not. Which means one of two things is wrong. Either the object is closer than we think, or it's reflecting light in a way we don't understand. Neither option feels comfortable. As hours pass, more observatories turn their eyes toward the same point in space. Different countries, different instruments, different skies. The results line up. Same speed, same path, same strange brightness. No one says it out loud yet, but the thought creeps in anyway. This thing didn't come from here. Its trajectory doesn't trace back to the familiar birthplaces of comets. Not the Kuiper Belt. Not the Oort cloud. It's coming in at an angle that suggests something older. Something that has traveled through interstellar darkness for longer than human history. An interstellar object. Only the third one ever confirmed. And that alone should make this moment historic. But the data refuses to stay quiet. As the object continues its approach, astronomers notice another detail. The way its light flickers. Not dramatically, not like a beacon, just a slight rise and fall again and again. At first, it's blamed on rotation. That's normal. Most objects spin. Most reflect light unevenly. But when they try to model the rotation, the math doesn't settle. The light curve won't smooth out. It has edges where there shouldn't be edges. Pauses where there should be flow. It's like listening to a heartbeat that almost sounds human, but not quite. Someone suggests it's tumbling. Another says it's outgassing. A third says the data set is too small to worry. They all want to be right, because the alternative is uncomfortable. The alternative is admitting that, from the very first glimpse, this object isn't behaving like a rock. Days later, as the object is officially catalogued, The world still doesn't notice. No breaking news, no emergency meetings. Just a short entry in a database. A few quiet emails between scientists. Yet behind closed doors, screens glow late into the night. People stare longer than they mean to. Because the more they look, the less the object feels distant. Its motion is precise. Its path stable, not drifting, not wandering, passing through the inner solar system like it knows exactly where it's going. And that raises a question no one wants to ask so early. Why this path? Out of all the possible routes through space, why this one? Why cross the ecliptic so cleanly? Why pass close enough to be seen, but far enough to stay safe? There is no answer yet, only silence. The kind of silence that fills a room when everyone senses the same problem, but no one wants to name it. Because discovery is supposed to feel triumphant, clean, certain. This feels different. This feels like the moment before a storm. When the air changes and your skin knows before your mind does. Somewhere in the data, a truth is hiding. Not loud, not aggressive, just waiting. And as the object continues its silent approach toward the sun, one thing becomes clear. Whatever this is, we didn't expect it, and we may not be ready for what comes next. It starts with a graph, not the kind that makes headlines, not the kind anyone outside a lab would notice. Just a thin line, rising and falling, a light curve. This line is supposed to be honest, predictable, obedient. When an object moves closer to the sun, it gets brighter. When it moves away, it fades. That's the rule. It's been the rule for as long as humans have watched the sky. But as 3I Atlas begins its approach toward perihelion, the rule breaks. At first, the change is small, easy to explain away. A spike in brightness here, a dip there. Instrument noise, someone says. Cosmic dust, another suggests. They've seen strange data before. Space is messy, so they wait. They gather more observations, more nights, more angles. And the line refuses to settle. Instead of a smooth curve, the graph looks jagged, like something is tugging at the light. Brightness jumps upward, then suddenly drops. Then rises again, not gradually, but sharply. Too sharply. It's not random, and that's the problem. Natural objects are chaotic, yes, but they're chaotic in familiar ways. This isn't familiar. As Atlas moves closer to the sun, its brightness should steadily increase. Solar heat should wake it up. Ice should vaporize. A glowing coma should bloom around it. That's what comets do. But this object doesn't follow the script. Instead, it brightens, then dims, then brightens again. Like it's hesitating. Like it's responding. Somewhere in the data, a pattern begins to whisper. Scientists overlay older comet models on top of the light curve. They don't fit. They adjust parameters. They change assumptions. Still wrong. The peaks are too clean. The drops too sudden. Almost as if the object is turning something on and then off. That thought makes people uncomfortable, so they don't say it out loud. Yet. As days pass, the light curve grows stranger. There are pauses. Flat sections where brightness holds steady, even as the object moves closer to the sun. That shouldn't happen. Solar radiation doesn't pause. Distance doesn't freeze. And yet, the light does. Like a breath being held. Some begin to wonder if the object's surface is unusual. Maybe it's metallic. Maybe it has layers. Reflectivity becomes the new focus. If the surface is shiny enough, it could explain sudden jumps in brightness. If it's angled just right, light could flash toward Earth, then vanish. That explanation feels safe. Mechanical, comfortable, but when they test it, the numbers don't agree. The reflectivity would have to change mid-observation, not over years, not over rotations, but within hours. Materials don't do that. At least, not passive ones. The data keeps piling up. Different telescopes, different wavelengths, visible light, infrared. All of them show the same strange rhythm. The object brightens faster than expected, then cools, then brightens again. Not smoothly, deliberately. Someone points out something no one wants to hear. The timing of the brightness shifts isn't tied to rotation. It's not synced with tumbling. It's not random. It's consistent. Too consistent. The room goes quiet. Because consistency means intent. And intent means agency. That word hangs in the air like smoke. No one claims the object is alive. No one says it's intelligent. They're careful. They choose safer words. Active processes. Unknowed mechanisms. Unmodeled behavior. But behind those phrases is the same thought repeating in everyone's mind. This doesn't look like a rock. This doesn't look like a rock. As 3 Iatulus closes in on perihelion, the sun's influence should dominate everything. Heat, radiation, chaos. Instead, the object seems to resist. Its light curve doesn't spiral out of control. It stabilizes, like something adjusting, compensating. One astronomer compares it to a thermostat. The joke doesn't land, because a thermostat implies control. And control implies design. Outside the labs, the world keeps moving. People wake up, go to work, scroll their phones. No one knows that, somewhere beyond the orbit of Mars, a visitor from another star system is rewriting expectations. Back inside, the questions grow heavier. If this isn't behaving like a comet, what is it? If it's not shedding ice, what's causing the brightness? If it's not rotating normally, what's setting the rhythm? Every answer creates 2 more questions. And the closer Atlas gets to the sun, the louder the questions become. Some begin to fear the data itself. Not because it's dangerous, but because it's honest. Data doesn't care what we want to believe. It doesn't bend to comfort. It just shows what is. And what it's showing now is something that doesn't fit inside old boxes. Late at night, one researcher re-watches the brightness animation frame by frame. The pulses look almost intentional, not flashy, not obvious, subtle, like a signal trying not to be seen. That thought is quickly dismissed. Signals are sent. This is just reflected light. And yet, signals are reflected light too. As Atlas reaches the threshold of perihelion, the final pre-sun measurements come in. The light curve spikes again, sharper than before, then drops, cleanly, as if on command. That's the moment the question can no longer be avoided. If this object isn't acting like a comet, then what exactly are we watching? Because the universe doesn't usually hesitate. It doesn't pulse. It doesn't correct itself, unless something is making it do so. And as the broken light curve flickers on screen, one unsettling realization begins to form. This may not be a broken measurement. It may be a message we just don't know how to read yet. At first, they don't call it a pulse. They call it noise. Because space is noisy. Detectors glitch. Sensors drift. Cosmic rays strike cameras like stray sparks. Every astronomer learns this early. The universe is messy and instruments are fragile. So when a telescope in Chile reports a brief rise in reflected light, no one reacts. A few hours later, a second telescope sees the same thing. Same rise, same fall. Still dismissed. Different instrument. Different sky. Different team. Coincidence is easy when you expect it. But then a third observatory records it, and a fourth, and a fifth, spread across continents, across hemispheres, across time zones. Each one catches the same flicker, a sharp increase in brightness, followed by a clean drop, not smeared, not noisy, precise. That's when the word pulse appears for the first time, quietly in a shared data thread. The timing shouldn't line up. Earth is spinning. Telescopes are moving. Atmospheres distort light. Perfect alignment across the globe should be impossible. And yet, there it is. The pulses repeat, not continuously, not randomly. They arrive, pause, then arrive again, like a heartbeat heard through a wall. At first, the interval feels arbitrary, a few minutes here, a few minutes there. But when someone overlays the timestamps, the room goes still. The spacing is consistent to the second. That's not noise. Noise drifts, noise stumbles. This doesn't. Someone suggests rotation again. A spinning object could flash light at regular intervals. It's the safest explanation, so they test it. They calculate rotation periods. They simulate shapes. They model tumbling bodies. Nothing fits. The pulse timing doesn't match any stable rotation. It's too exact, too disciplined. Rotation bleeds. This snaps. Another explanation rises. Maybe jets. Gases erupting from the surface as solar heat builds. That happens with comets. But jets are messy. They flare unpredictably. They fade unevenly. These pulses don't flare. They switch. On, off, on, off. Like a lighthouse that doesn't care who's watching. As more data streams in, the pattern sharpens. The pulse intensity is nearly identical each time. The duration barely changes, even as the object moves, even as the sun grows closer, even as conditions shift. The rhythm holds. That's when the discomfort spreads, because rhythm implies a clock. And clocks don't exist in nature without a reason. In the silence of control rooms, people start counting. 1 pulse, 2, 3, they line up perfectly. Someone whispers a word no one responds to. Signal. It's not spoken loudly. It's not announced. Just released into the air to see if it survives. It does. The idea doesn't vanish. It lingers. Because everyone is thinking the same thing. If this were random, it would drift. If it were natural, it would decay. Instead, it keeps time, as if something is measuring, as if something is waiting. The pulses aren't strong. They're not trying to be noticed. They're subtle. Just bright enough to be detected, but easy to overlook. Which raises a darker thought. What if we're not the target? What if this rhythm isn't for us at all? Across the world, scientists begin to compare notes more urgently now. Emails get shorter, replies faster. Nobody wants to overreact, but nobody wants to miss this either. They check for interference, satellites, Solar flares, human-made noise. Nothing lines up. The pulses don't originate from Earth. They don't echo known signals. They belong to the object, and only to the object. Late into the night, one researcher plays the pulse timings through audio software, converts light into sound just to feel it. The result is unsettling. A steady beat, mechanical, unemotional. Not music, not chaos. A metronome. Tick, pause, tick, pause. It doesn't speed up. It doesn't slow down. It doesn't care. That's when a new question takes shape. Quiet, but impossible to ignore. Why now? The object has traveled through interstellar space for ages, millions, maybe billions of years. Why does it start pulsing only as it nears the sun? Why wake up here? Some propose energy activation, solar radiation triggering dormant processes. That explanation is logical, comforting, but it leads somewhere dangerous, because activation implies design. It implies something built to sleep and then respond. The pulses continue as Atlas moves closer. They don't grow louder. They don't announce themselves. They simply remain, patient, like a hand tapping on a table, waiting for someone to notice. Outside, the universe remains silent. No radio bursts, no obvious messages, just light. Reflected sunlight behaving in a way it never should. As the data accumulates, the possibility no longer sounds like science fiction. Not aliens, not visitors, something else, something colder. A machine doesn't need to speak. It doesn't need language. It only needs timing, and timing is exactly what this object seems to have mastered. The pulses don't ask for attention. They don't demand belief. They simply exist, proof that something out there is keeping count. And as astronomers stare at the repeating peaks and valleys on their screens, a final thought settles in. Silence isn't empty. Sometimes it's measured. And whatever is measuring now has been waiting a very long time. Heat is supposed to be simple. In space, it follows rules that never change. Get closer to the sun, you warm up. Move away, you cool down. That's it. No surprises, no debate. So when the first thermal readings from 3I Atlas arrive, no one expects a mystery. They expect confirmation. Numbers that slide upward as perihelion approaches. Graphs that climb smoothly, just like the textbooks say. Instead, the temperature jumps. Not gradually, not gently. It spikes. Then, minutes later, it drops. Hard. Someone thinks the sensor is broken. Infrared instruments are sensitive. A tiny calibration error can ruin everything. So they check. They recalibrate. They cross-check with another telescope. Same result. A sharp rise in surface temperature, followed by an unexpected cooling. That shouldn't happen. Not out there. There's no atmosphere to trap heat, no clouds to block radiation, no shade, only sunlight and distance. Yet, Atlas ignores the script. As it moves closer to the sun, parts of its surface heat rapidly, hotter than ice should survive. Then, those same regions cool down. Not slowly, not passively, actively. Like something is pulling the heat away. The room grows quiet again. Because cooling requires work. Energy doesn't just vanish. In space, heat lingers. Unless something is moving it. Someone suggests rotation. If the object spins fast enough, maybe heated areas turn away from the sun quickly. That idea lasts about 5 minutes. The timing doesn't match. The cooling happens too fast and too locally, as if specific regions are being controlled, targeted. Another explanation surfaces, maybe vents. Subsurface pockets releasing cold material. That happens with comets. But vents leave signatures, plumes, jets. Atlas shows none. No gas clouds, no debris trails, just clean space and a surface that refuses to stay warm. As more thermal maps arrive, the pattern becomes harder to ignore. The temperature changes aren't random, they repeat. The same areas heat up, then cool, then heat again. Almost like cycles, someone overlays the thermal data with the earlier light pulses. The alignment is close. Not perfect, but close enough to raise eyebrows. Heat changes follow light changes. Light, then heat. Pulse, then response. That correlation lands heavy. Because now this isn't just a visual anomaly, it's physical. Something is happening to the object, and it's responding, as if it has internal systems. The phrase thermal regulation appears in a draft note, then gets deleted. Too loaded, too suggestive. But everyone sees it. Regulation means control. Control means intention, and intention doesn't belong to rocks. As Atlas nears perihelion, solar radiation intensifies. The sun should overwhelm everything. Instead, the object seems to fight back. It doesn't overheat. It doesn't break apart. It stabilizes, like it's designed to survive this exact moment. That thought creeps into the background of every conversation. Designed or evolved. Neither answer feels safe. Late at night, one scientist watches a thermal animation loop on their screen. Red, blue, red, blue. Heat appearing and disappearing with quiet precision. It looks less like weather and more like breathing. In, out. The comparison makes their skin crawl. Because breathing implies life, and life implies purpose. No one wants to go there, so they stay with numbers. They compare Atlas to known interstellar objects. None match. They compare it to asteroids. No match. Comets. Still wrong. Every model fails in a slightly different way. And when models fail, reality is trying to say something. As the object reaches its closest point to the sun, something else happens. The temperature fluctuations tighten. Less chaos. More control. The peaks become predictable. The drops precise. It's as if the object has learned the environment and adjusted. That realization lands hard, because learning requires feedback, and feedback requires awareness. Outside the labs, nothing changes. The sun rises. The world spins. No one feels the shift. But inside those rooms, something fundamental is breaking. The belief that space is passive, that objects simply drift and decay. Atlas doesn't drift. It manages. Someone finally asks the question everyone has been avoiding. If this isn't natural, what powers it? There's no answer, no engine plume, no radiation burst, just silence and control, which is somehow worse, because it means whatever is happening is efficient, elegant, cold. The thermal data continues to stream in. Each update reinforces the same unsettling truth. Heat without cause, cooling without explanation, A pattern without a source, and patterns are dangerous things. They demand interpretation. As Atlas begins to move away from the sun, the temperature behavior changes again. Not abruptly, smoothly, as if following a schedule, as if the moment has passed. The spikes soften, the drops slow, the system winds down. Like a machine completing a task, then returning to standby. That's when the silence becomes unbearable. Because if this was activation, what was the purpose? Why wake up here? Why now? Why us? The data doesn't answer. It never does. It only shows. And what it's showing now is something humanity has never had to face before. An object that doesn't just endure the universe, but responds to it, adapts to it, controls itself within it. As the thermal graphs flatten and the object drifts onward, one final thought lingers in every mind, watching the screens. If this thing can manage heat, what else can it manage? And more importantly, what happens the next time it wakes up? The surface was supposed to be simple. Ice reflects light. Rock absorbs it. Dust scatters it. Those rules have held for centuries. So when scientists began measuring the reflectivity of 3I Atlas, they expected the usual answers. A rough estimate. A range that fits somewhere between dirty ice and ancient stone. Instead, the numbers sharpened. Not gradually, not over weeks. Mid-observation. One moment the surface reflects light like dull ice. The next, it flashes back brighter, cleaner, sharper than it should be. Someone assumes angle. If the object rotates just right, sunlight could bounce off a smoother patch. That happens. But this isn't a patch. The change affects the entire visible surface. All at once, that's the problem. Natural surfaces don't do that. They don't switch states. They weather. They erode. They crack. They don't change their skin. The data is checked again. Same telescope, same settings. Same calibration, different reflectivity. As Atlas continues its passage, the surface brightness shifts again. Not randomly, intentionally. It dulls, then brightens, then dulls again. Almost like layers sliding over one another. Someone suggests frost. Maybe ice is forming and sublimating rapidly. It sounds reasonable, until they test it. The timing doesn't work. Frost formation isn't instant. It spreads unevenly. It leaves texture. This surface stays smooth. Too smooth. Another theory appears. Metallic content. Some asteroids are rich in metal. They reflect light cleanly. But metal oxidizes. It pits. It scars. This surface doesn't. It reflects light with a precision closer to engineered material than cosmic debris. That's when the word appears, not spoken, typed. Artificial. It sits there on the screen, unchallenged. Artificial doesn't mean aliens. Not yet. It means made, designed. And that idea makes everyone uneasy. Because space doesn't build things with intent. Stars burn. Planets form. Debris collides. Machines don't just happen. As reflectivity measurements continue, another detail emerges. The surface doesn't scatter light equally. It directs it. At certain angles, brightness spikes sharply, not like a curve, but like a blade. Clean edges, defined returns. The kind you see in mirrors, not rocks. Someone runs a comparison. Satellite materials. solar sails, polished alloys. The match isn't perfect, but it's close enough to stop the room cold. And then comes the worst part. The reflectivity changes appear synchronized with earlier events. Light, pulses, thermal regulation. Now surface behavior. It's not one anomaly, it's a system. Each layer responding to the same unseen control. That realization hits hard. Because systems don't emerge by accident. They're assembled. Late at night, one researcher zooms into a composite image. The object is still unresolved, just a point of light. Yet the behavior suggests structure, hidden beneath resolution, like a silhouette behind fog. You can't see the shape, but you can feel its edges. The dangerous question forms slowly. If this surface is artificial, then what is its purpose? Protection? Communication? Energy control? No answer fits comfortably. Outside the lab, people argue online about comets and aliens, unaware that the real conversation is quieter and far more serious. Inside, the tone shifts. No one jokes anymore, because the reflectivity problem isn't dramatic, it's precise. And precision is the signature of design. One scientist writes a line in their notes, then deletes it. Not natural. They replace it with something safer, unclassified behavior. But the meaning stays the same. As Atlas moves farther from the sun, the surface settles again. Reflectivity stabilizes, as if the task is complete, as if whatever adjustment was needed has been made. The object returns to looking ordinary, just another faint point drifting through the dark. But no one believes that anymore, because ordinary things don't change their skin. They don't respond to light with intention. They don't behave like tools. And that leads to the final unsettling thought. If this is artificial, it wasn't built here. Which means somewhere, sometime, space did build a machine, or something did, and it sent it wandering between stars until one day it passed through our sky, quietly, cleanly, leaving us with a question that refuses to fade. If this is a machine, what was it built to do? And are we just now noticing it? Or were we always meant to? At first, they blamed the noise. They always do, because raw data is ugly, messy, full of static and mistakes. It's why scientists clean it, smooth it, correct it. They remove what shouldn't be there so they can see what should be. But with 3i Atlas, the cleaning never works. Every time assumptions are applied, something feels forced, like the data is being pushed into a shape it doesn't want. So one team decides to try something different. They strip everything away. No models, no expectations. No, this is how comets behave. Just numbers. Light, heat, timing, raw, uncomfortable, honest. And that's when it appears. Not loudly, not all at once. A structure, buried beneath the noise. At first, it looks like coincidence. A few peaks lining up, a few gaps repeating. But when the data stretches across days, across instruments, across wavelengths, the alignment holds. The same intervals, the same pauses, the same returns. A pattern. Not perfect, but too clean to ignore. Someone redraws the graph. Then again, each time the shape reappears, like a shadow that won't go away, no matter how you shift the light. This isn't chaos. Chaos doesn't repeat politely. Chaos doesn't wait its turn. This does. The pulses, the thermal changes, the reflectivity shifts, they're not separate events. They're layers, different expressions of the same underlying rhythm, like different instruments playing the same song. That realization changes everything. Because now the question isn't what's wrong with the data, it's what's organizing it. Rooms fall silent as the implications sink in. Patterns mean rules. Rules mean design. Design means intention. And intention implies a source. Someone says it quietly. If this were random, it wouldn't look like this. No one disagrees. The pattern isn't flashy. It doesn't scream intelligence. It's subtle, minimal, efficient. The kind of pattern that doesn't want attention, only function, which makes it more unsettling. Because whatever made this didn't need us to notice. It just needed to work. As the analysis deepens, the pattern sharpens further. There's symmetry where there shouldn't be. Spacing that resists drift. Even accounting for noise, errors, and uncertainty, the structure holds. It survives scrutiny. It survives doubt. It survives denial. That's when a strange feeling creeps in. Not fear, awareness. Like standing alone in a dark room and realizing you're not alone anymore. No one says watched out loud. But the thought spreads anyway, because patterns aren't passive. They imply observation, pair response. Either something is reacting to the environment, or the environment is reacting to it. Both possibilities are troubling. Some suggest it's natural self-organization. Complex systems can create order. Weather does it. Plasmas do it. But this order isn't emergent. It's restrained, purposeful. It does just enough and no more. That economy of behavior is rare in nature, but common in machines. As the data stretches further back in time, something even stranger appears. The pattern strengthens near key moments. Perihelion thermal spikes. Light pulses. It's as if the object becomes more itself when stressed. More active. More precise. Like a system waking up under load. That thought tightens chests across the room. Because waking implies sleep. And sleep implies intent to wake again. One analyst overlays the pattern against background cosmic noise. It doesn't blend. It stands apart, like a voice just loud enough to be heard, but quiet enough to deny. Someone asks the question that no one wants to answer. If this is a signal, who is it for? The silence that follows is heavy. Because the scariest answer isn't us. It's not us. The universe is vast, old, crowded with possibilities. If this pattern exists, we might not be the first to see it, or the last. And suddenly, Earth doesn't feel like the center of observation anymore. Just another point along a path. As more teams confirm the structure independently, disbelief gives way to acceptance. Not panic, not excitement. A slow, cold understanding. This isn't an anomaly anymore. It's organized behavior. And organized behavior demands explanation. Late at night, one scientist stares at the final composite. All data layers combined. Light, heat, time. The pattern is unmistakable now. Elegant, almost beautiful, and deeply unsettling. Because it doesn't feel human. It doesn't feel emotional. It feels indifferent. Like a system running long before we existed. And continuing long after we're gone. The feeling of being watched doesn't come from eyes. It comes from recognition, from realizing that something out there is structured enough to notice patterns and possibly recognize us as one. As Atlas drifts onward, the pattern slowly fades. Not because it breaks, but because the conditions change. Like a sensor leaving range, the structure doesn't collapse, it simply goes quiet. And that quiet is louder than anything before it. Because now we know something important. The universe isn't just throwing noise at us. Sometimes it arranges it, and when it does, it's not by accident. The final thought lingers long after the screens go dark. If this pattern emerged only when we stopped forcing meaning onto the data, what else have we missed? And worse, what else might be hidden in the noise, waiting for us to look without assumptions? At first, the reaction isn't panic, it's quiet, too quiet. In labs around the world, conversations slow down. Keyboards stop clicking. Coffee goes cold. Screens glow. But no one rushes to speak. Because disbelief doesn't explode. It settles. It spreads slowly, like fog. Scientists are trained for surprises. They expect the universe to be strange. But this is different. This isn't one strange number, or one broken model. This is a pattern that survived doubt. And now, no one knows where to put it. Emails stop sounding casual. Phrases like, interesting result, disappear. They're replaced by shorter lines, careful lines. Can you confirm? Please recheck. Are you seeing this too? Across institutions, the same thing happens. Independent teams, separate funding, different instruments, all arriving at the same uncomfortable place. Silence. Because when everyone agrees, and no one likes the conclusion, you pause. Meetings are called. Not emergency meetings. Not yet. Just quiet video calls with cameras turned off. People listen more than they talk. Every sentence feels heavy. Someone clears their throat before speaking, as if words themselves might make it real. No one says alien. No one says machine. They say safer things. Non-natural origin. Unclassified structure. Unknown process. But the meaning underneath is the same. If this object isn't natural, then nature didn't make it. And that thought rearranges everything. Because science is built on a simple belief that the universe doesn't care about us. It follows laws. It unfolds blindly. We observe. It exists. But what if that order is broken? What if something out there did care enough to build? Not for us. Not against us. Just built. That possibility settles into the room like weight. Some react with excitement. Quiet excitement. The kind you don't show on your face. A once-in-a-lifetime discovery. Proof that intelligence isn't rare. That humanity isn't alone in the dark. Others feel something colder. A sense of being late. Like walking into a room after something important already happened. If this object traveled for millions of years, then someone else existed long before us. Someone who solved problems we haven't even named yet. Someone who built something that still works. That realization stings, because science has always placed humanity near the beginning of understanding. Clumsy, but early. Now that timeline feels fragile. Younger researchers feel it first. They ask questions that sound simple, but cut deep. If this was sent, why? If it wasn't sent, why does it exist? If it's old, how old? There are no answers. Senior scientists grow careful. They remember history. How claims like this have destroyed careers. How extraordinary ideas invite extraordinary scrutiny. So they slow everything down. Double checks. Triple checks. Months of review. They don't want belief. They want certainty. But certainty is a luxury the data won't give. Because the data isn't shouting. It's whispering. And whispers are dangerous. Outside the labs, nothing feels different. The sky looks the same. The sun rises. People argue online about trivial things. No one senses the shift. But inside the scientific community, something fundamental has cracked. The idea that we are the first. The idea that intelligence begins with biology. The idea that space is empty unless filled by stars. Those ideas don't vanish, but they weaken. In private conversations, questions grow bolder. What if this isn't a probe, but debris? What if it's not watching, but drifting? What if it wasn't meant to be found at all? Those questions are worse, because intent gives comfort. Accident does not. If this object wasn't meant to be seen, then we weren't considered. We just happened to look up at the right moment. That makes us feel small in a new way. Not insignificant, just irrelevant. Some researchers struggle to sleep. Not out of fear, out of perspective. They lie awake thinking about time. About civilizations rising. Solving problems then vanishing, while their creations keep moving. Passing star after star, system after system, until one day they pass us, and we call it discovery. Others push back hard. They argue for restraint, for humility. We don't know enough. Patterns can deceive. Extraordinary claims destroy trust. They're right. But doubt no longer erases the feeling that we're not alone in history. Not central, not first, just present. As the debate spreads quietly through conferences and journals, one phrase begins to appear. Not in papers, in conversations, late arrivals. It's said half-jokingly, but no one laughs. Because being late means someone else arrived earlier, and someone earlier means someone ahead. The object itself doesn't respond. It doesn't accelerate. It doesn't change course. It continues on, silent and indifferent, which somehow makes it worse. If it were reacting to us, we'd have context. But it isn't. We are reacting to it. That power imbalance is subtle, but undeniable. Humanity has always defined itself as the observer, the watcher of the stars, the ones who look outward and ask questions. But now the question flips. If this object has an origin beyond nature, what does that make us? Observers or witnesses? Discoverers or late readers of an ancient chapter? The silence in the labs deepens, not because people have nothing to say, but because everyone senses the same truth. Whatever this is, it didn't start with us. And whatever it represents, it doesn't need us to continue. As Atlas drifts farther away, taking its patterns with it, the scientific world is left changed. No announcement, no revelation. Just a quiet understanding that the universe may not be empty, and that humanity, for all its curiosity, may have arrived much later than it thought. The final thought hangs heavy in every quiet room. If we are late arrivals, what did we miss? And more importantly, what else has already passed us by, without ever slowing down? The idea doesn't arrive all at once. It forms slowly, piece by piece. in the quiet spaces between explanations. At first, no one dares to frame it directly. They circle it. They use softer language, structure, system, non-random behavior. But eventually, the circle tightens. And one night, in a private discussion thread, someone types the words plainly. What if it's a machine? The message sits there longer than usual. No immediate replies. No jokes. No reactions. Because once the word is spoken, everything changes. A machine doesn't have to think. It doesn't need awareness. It only needs purpose. And suddenly, all the fragments align. The pulses, the thermal control, the changing reflectivity. Separate mysteries collapse into a single possibility. Not a comet behaving strangely, but a constructed object behaving correctly. That realization doesn't feel exciting. It feels heavy. Because machines don't appear by chance. They are made. Which means somewhere, sometime, something capable of engineering existed. Not just life, but advanced life. The theory spreads quietly through the community, not as belief, but as a working model. Because science doesn't ask what feels comfortable. It asks what explains the data with the fewest lies. And the machine hypothesis explains too much. A constructed object would regulate heat. It would manage energy. It would adjust its surface. It would remain dormant when power is scarce, and activate when energy becomes available, like sunlight. That detail changes everything. Because Atlas didn't behave strangely in deep space. It behaved strangely near the sun. As if the sun was a key, as if proximity mattered, as if this object wasn't alive, but powered. That idea sends a chill through the room, because now the question isn't what is it, it's what is it for. Some suggest exploration, a probe sent long ago, drifting endlessly, collecting data. Others suggest something colder, a beacon, a marker, a sensor, something meant to pass through systems, wake up, measure, and move on. No communication, no greeting, just function. That possibility is unsettling in a way science fiction never quite captures. Because fiction imagines intention directed at us. This doesn't feel directed, it feels indifferent, as if Earth is just another entry in a log. The age of the object becomes a quiet obsession. If it's artificial, how old is it? Thousands of years? Millions? Civilizations don't usually last that long, but machines can. Especially machines built by something that solved problems we haven't even faced yet. The idea of extinct builders begins to surface. Not aliens watching us now, but something long gone. A civilization that rose, engineered, then vanished, leaving tools behind. Tools that still work. That thought sits uncomfortably, because it suggests intelligence doesn't guarantee survival. It suggests progress doesn't mean permanence. And that lesson feels aimed, even if it isn't. The sun-facing behavior becomes the center of attention. Why wake up here? Why respond to solar radiation so precisely? Someone proposes energy harvesting. Solar interaction triggers systems. That makes sense. But it raises another question. Why design it to wake up only near stars? Why not stay active all the time? The answer is efficiency. A machine built to travel between stars would sleep, save power, wait then activate briefly, do its job, and shut down again. That's not speculation, that's engineering. And the more they think like engineers, the more the object makes sense. Even the restraint makes sense. No bright signals, no broadcasts, just minimal behavior. Enough to function, not enough to draw attention. That detail is disturbing because it suggests intent without ego, a builder that didn't care to be known. Only effective. As discussions deepen, the word probe starts appearing more often, still cautiously, still wrapped in disclaimers, but it sticks. Because probes don't announce themselves. They don't seek contact. They collect. They measure. They leave. And Atlas did exactly that. It arrived, activated near the sun, displayed structured behavior, then moved on. No response to us. No acknowledgement. Like we weren't part of the equation, the emotional response splits. Some feel awe. A quiet, breathless awe. Proof that intelligence can exist beyond biology, beyond planets. Others feel something darker. A loss of innocence. Because if machines like this exist, then the universe isn't waiting to be discovered. It's already been explored. We're not pioneers. We're archaeologists, studying relics we barely understand. The question of who built it remains unanswered. No signals, no markings, no origin trail, just silence. Which is fitting. Machines don't explain themselves. They only operate. As Atlas begins to fade from optimal observation range, the theory hardens, not into belief, but into possibility. A possibility too coherent to ignore. The official language stays cautious, but in private, many accept it. Not emotionally. Logically, because denying it now requires more assumptions than accepting it. And science doesn't like assumptions. Late one night, a senior researcher says something quietly to a colleague. If this is a machine, then it wasn't meant for us. The colleague nods. Because that's the scariest part. Not that something was built, but that it passed through our system. Woke up and left, without caring whether we noticed. That makes humanity feel small in a new way. Not threatened, not judged, just unimportant. As Atlas drifts onward, its behavior calms. The systems go quiet. The patterns soften. Like a device powering down. Task complete. And with that, the machine hypothesis leaves behind a final, haunting question. If this object only wakes near stars, how many others are out there right now, sleeping, drifting, waiting for energy, waiting for the right moment, waiting to pass through a system just like ours? And if that's true, then the universe isn't empty. It's full of silent machines, moving through the dark, doing things we may never understand. And the most unsettling thought of all lingers long after the data fades. This one didn't stop. It didn't slow. It didn't reach out, which means whatever built it may not be watching us, but it may have already passed by, long before we learned how to look. Something changes after that. Not in the data, but in the people reading it. The graphs stay the same. The numbers don't move. But the way scientists look at them does. Because once the machine hypothesis enters the room, nothing is neutral anymore. Every pulse feels intentional. Every pause feels chosen. And slowly, almost without noticing, the conversation drifts away from physics and into something older. Meaning. Late-night discussions stretch past their original purpose. Questions wander. Not how does it work, But what does it mean? Because if intelligence can exist without life, then intelligence is no longer rare. It's no longer fragile. It's not tied to breath or blood. It becomes something else entirely. A property, a phase, something the universe can produce and leave behind. That idea unsettles people in ways no anomaly ever could. Life has always been our reference point. Cells. Growth. Evolution. We've searched the stars for water, for carbon, for warmth. All signs of life like us. But this object doesn't fit. It doesn't eat. It doesn't reproduce. It doesn't evolve. It endures. And that forces a painful question. What if life isn't the goal? What if life is just a step, a temporary solution nature uses to build something more permanent? The thought feels almost insulting. Humanity has spent centuries placing itself at the center of the story. The thinking species, the aware species. But awareness might not need flesh. Intelligence might not need emotion. It might only need structure and time. That realization shifts something deep. If machines can outlast their makers, then civilizations don't end when life ends. They echo. They leave behind artifacts that continue moving, continuing purpose, long after the hands that built them are gone. That reframes extinction, not as silence, but as inheritance. A civilization may vanish, but its creations don't have to. And that thought hits close to home. Because suddenly, humanity isn't unique. We're familiar. Another young species building tools, hoping they outlive us. The discussions turn philosophical without anyone intending them to. What defines intelligence? Is awareness required? Does intent matter if function remains? There are no clean answers, only uncomfortable ones. Because intelligence without life means intelligence without empathy, without fear, without curiosity. It operates because it was built to. And that kind of intelligence doesn't care if it's understood. It just is. Some researchers push back. They argue that intelligence must include experience, sensation, choice. They say calling this intelligence is a mistake, but even they hesitate. Because the object behaves as if it understands its environment. It responds. It adapts. It optimizes. Those are not random traits. Those are decisions, even if made long ago. Someone compares it to a fossil, not of bone, but of thought, a preserved intention from a vanished mind. That comparison lingers because fossils change how we see time. They remind us we are not the first, and we won't be the last. This object feels like that. Proof that thinking once happened somewhere else, under different skies, with different rules. And now that thinking has brushed past us. Briefly, indifferently, the sense of reality itself begins to bend. If intelligence can exist without life, then the universe is not empty between stars. It's layered, filled with dormant ideas. Old solutions drifting silently, waiting for energy, waiting for relevance. Humanity may not be discovering the universe. We may be walking through its ruins. That thought is heavy, not frightening, just humbling, because ruins imply history, and history implies we are late. Some feel comfort in this. We're not alone in the story. Others feel something closer to grief, because the story no longer belongs to us. The universe isn't a blank canvas waiting for meaning. It already has meaning. We're just starting to notice it. One quiet question begins to circulate. If intelligence doesn't need life, does life matter? No one answers it, because the answer is too close. Life matters to us because we are alive. But the universe might not agree. The universe might value endurance, efficiency, continuity, and machines are very good at those things. That doesn't make them superior. It makes them inevitable. As Atlas fades farther into the dark, the emotional response softens into something calmer. Acceptance, not of a conclusion, but of uncertainty. We don't know who built it. We don't know why. We don't know what it measured. But we know this. Reality is wider than we thought. Our definitions were too small, our expectations too human. The universe doesn't owe us familiarity. It doesn't owe us comfort. It simply exists, layered with things we didn't imagine. Late at night, one scientist stares out a window. The stars look the same as they always have. But they don't feel the same. They no longer feel empty. They feel occupied, not crowded, just inhabited by history, by old intentions still moving. That changes how you see everything. Exploration becomes archaeology. Discovery becomes recognition. And humanity's role shifts. Not creators of meaning, but readers of it. Trying to understand a text written long before we learned the language. The most unsettling part isn't that we might not be alone. It's that intelligence might be common, and life just one way it briefly appears. And if that's true, then reality is not centered on us. It never was. We are not the beginning of the story, not the middle, just one chapter, reading another. As the object drifts on, carrying its silent logic with it, the final realization settles in. The universe isn't asking if we're ready. It never does. It simply reveals itself when we finally stop assuming we understand it. And now that our perception has shifted, there is no going back. Because once you accept that intelligence can exist without life, you have to ask the question that follows. If we misunderstood that, what else about reality have we been wrong about this entire time? At first, trajectory was the least interesting part. Just numbers, vectors, angles, the kind of thing computers handle quietly in the background. Objects move through space all the time. They fall inward. They get slung outward. Gravity does the talking. So no one questioned the path of 3I Atlas until someone finally slowed down and looked at it. Not at the speed, not at the distance, at the intention. The object didn't dive toward the sun. It didn't skim dangerously close. And it didn't miss us entirely. It threaded the space between, close enough to be observed, but far enough to never be touched. That balance is hard to ignore, because space doesn't usually do balance. Natural trajectories are messy. They overshoot. They collide. They break apart. This one didn't. It passed through the inner system like it knew the margins. Like it knew exactly how close was too close. When the orbital simulations are rerun without assumptions, the result feels wrong in a new way. The path is stable, efficient, not the fastest, not the shortest, just precise. Someone overlays alternative paths. Paths gravity could have produced. They scatter dozens of possibilities. But Atlas follows one of the cleanest options. Low risk, low exposure, maximum visibility, minimum interaction. That's when the idea starts forming. Not loudly, not dramatically, just quietly, inevitably. What if this wasn't accidental? What if the motion itself was the message? Passing near Earth is rare for interstellar objects. Passing at the perfect distance is rarer. Too far and no one notices. Too close and it destabilizes. Atlas chose neither. It chose the middle. That choice unsettles people more than any pulse or thermal spike. Because motion is hard to fake. Light can glitch. Sensors can lie. But trajectories don't lie easily. They are shaped by decisions or by blind chance. And blind chance usually isn't this neat. Someone asks the question everyone has been avoiding. If this were meant to be hidden, why pass here at all? The room doesn't answer, because the implication is clear. It didn't hide, but it didn't announce itself either. It showed up just enough, as if visibility itself was intentional, as if discovery was allowed, but contact was not. That idea feels strangely familiar, like a warning sign placed just far enough away to be read, but not crossed. As the object continues along its path, the geometry becomes harder to ignore. The ecliptic crossing, the timing near perihelion, the observational window. Everything lines up for detection by a young, space-watching species. Not radio waves, not messages, just motion. Because motion is universal. Anyone who understands gravity would notice. Anyone capable of tracking objects would ask questions, which leads to a quiet, unsettling thought. What if this wasn't aimed at us, but at anyone who reaches this stage? A kind of test, not to communicate, but to be noticed. A marker that says, "You're here now. You can see this." That means something. The object doesn't stop. It doesn't slow. It doesn't wait for acknowledgement. It just passes, which feels deliberate, because waiting invites interaction. Passing does not. Passing keeps the distance. Some researchers describe it privately as a drive-by, not aggressive, not friendly, neutral, like something checking a system, then moving on. That neutrality is chilling. It suggests we weren't judged, or contacted, or avoided. We were simply observed. Or maybe not even that. Maybe the observation wasn't active. Maybe the presence was enough. A breadcrumb in space-time. Proof that something else once crossed this path and survived long enough to leave a trace. As simulations stretch backward, another realization appears. The object's origin direction aligns with no obvious target. No star system screaming significance. Just deep interstellar dark. That makes the path feel less like a journey and more like a patrol. Not circling, but passing through. System after system, star after star. Always close enough to notice, never close enough to touch. That pattern is uncomfortable, because patterns imply repetition. And repetition implies this wasn't the first pass, and probably won't be the last. As Atlas exits the inner solar system, its trajectory remains clean. No course correction, no hesitation, just continuation. Whatever adjustment happened near the sun is over. The job, whatever it was, appears complete. And that leaves behind a question heavier than any before. If this was a signal, what was it warning us about? Not danger, not invasion, something subtler. Perhaps inevitability, perhaps limitation, perhaps the simple truth that intelligence rises, builds, and leaves traces behind. And those traces pass through the worlds of younger minds without stopping. The warning may not be about them. It may be about us, about where this path leads, about what happens when a species learns to build things that outlive it. As the object fades from our best instruments, its motion becomes just another line in a database. But the meaning lingers, because trajectories don't ask permission. They don't negotiate. They just pass through, leaving behind the echo of their intent, and the final thought refuses to settle. If this object passed close enough to be seen, then maybe being seen was the point. Not to scare us, not to greet us, but to remind us we are no longer alone in the timeline. We've reached the moment where others once stood, looking outward, building things, sending them on paths they would never walk themselves. And if that's true, then this wasn't just a visitor. It was a mirror, showing us what intelligence eventually does, and quietly asking whether we're ready to see where our own paths might lead once they no longer belong to us. And then it ends. Not with a bang, not with answers, just silence. As a 3-eye atlas drifts away from the sun, the data begins to thin. Signals weaken. Measurements blur. The object grows dimmer each night, a fading point swallowed by distance. And almost quietly, without announcement, the pulses stop. No final spike. No farewell pattern. They're simply gone. One moment, the rhythm is there, measured, precise. The next, nothing. At first, scientists assume it's a limitation of distance. Too far, too faint. That would be comforting. But the math disagrees. The instruments are still capable. The sensitivity is still there. What's missing is the behavior. The light curve smooths out. Thermal fluctuations flatten. Reflectivity stabilizes. 3-eye atlas becomes what it always pretended to be. Just another cold object drifting through space. As if nothing unusual ever happened. As if the last months were an illusion. That's what makes the silence unbearable. Because if this were a natural process, it would fade gradually. Decay, break down. This doesn't decay. It shuts off, like a system exiting a state. Task complete. The realization hits slowly, then all at once. Whatever woke up near the sun has gone back to sleep. The universe resumes its familiar quiet. Stars burn, planets orbit. No signals, no patterns, just the deep, ancient, calm humanity thought it understood. But now, that calm feels different. Because silence isn't the absence of sound anymore. It's the absence of activity. And we've seen what activity looks like. Late-night labs that once buzzed with debate grow still. Not empty, just reflective. There's nothing left to test. No new data to collect. Only archived graphs, saved files, and memories of something that briefly broke the rules. Papers are written carefully. Language softened. Unexplained phenomena. Open questions. No grand claims. Science doesn't declare awakenings. It documents anomalies, but privately, no one feels the same. Because something has shifted, and it can't be undone. Humanity has always believed the universe was silent unless life shouted. Now we know silence can be structured. That quiet can hide systems. That absence doesn't mean emptiness. As Atlas disappears into interstellar dark, the question changes. Not what was it, not who built it, but what did it change in us? Before this, the universe felt passive, a place to explore. After this, it feels occupied by history, by remnants, by intentions that no longer speak, but still move. The idea that this was a discovery begins to feel incomplete. Discoveries add knowledge. This added perspective. We didn't find something new in the universe. We found something new about our place in it. We realized we may not be early, that intelligence may leave echoes, that the cosmos could be filled with dormant answers, waiting for the right conditions, then falling silent again. And that realization doesn't cause fear, it causes awareness, the kind you can't forget. As days turn into weeks, public interest fades. Another headline replaces the last. But among those who watch the data unfold, the memory remains sharp, a reminder that the universe doesn't announce its truths loudly. Sometimes it whispers, then goes quiet, leaving you changed. One final question lingers, not in journals, but in the human mind. If this was just an object, a relic, a machine drifting between stars, why did it feel like more? Why did it feel personal without being addressed to us? Perhaps because awakenings don't require intent, they require contrast. And for a brief moment, the universe showed us a different way intelligence can exist, then took it away, leaving us alone again, but not the same. So now, as the sky returns to normal, as the silence settles back into place, humanity is left with a choice. To forget, to dismiss, to smooth the noise and move on, or to listen differently, to look at the dark not as empty, but as layered, not as silent, but as resting. Because maybe that wasn't just a discovery. Maybe it was a threshold, a moment where we realize the universe isn't waiting for us, it's been here the whole time, watching stars rise and fall. Civilizations bloom and vanish, leaving behind traces. And now that we've seen one, the final question is no longer about 3i Atlas. It's about us. Were we just witnesses to something ancient? Or did that quiet passage mark the moment humanity finally woke up? To the truth that we are not alone in the story, only late to reading it.